So hi everyone, good evening. In the last video we have seen about inductive effect and application of inductive effect. Now we are going to learn about the mesomeric effect. Okay, but before going to mesomeric effect, I must say that you should know it very well what is conjugation in organic chemistry. Conjugation is a very important concept which is used in different concept in different topics, and it is most widely used concept. For example, you will see it is used in the resonance, in mesomeric effect, again in aromaticity, again in hyperconjugation, conjugation. There are different types of conjugation. Already I told you in the last class. They are pi, sigma negative charge, pi, sigma lone pair, pi, sigma positive charge, lone pair, sigma positive charge. So these are all different types of conjugation. So what is conjugation in organic chemistry? Conjugation is a system of overlapping p orbitals which leads to the delocalization of pi electrons, and ultimately increases the stability. So you must say, what is conjugation? Conjugation is the system of overlapping p orbital and increasing the pi electron delocalization and ultimately increase in the stability of a compound. Okay. So what are the different types of conjugation exist? Before going to different types of conjugation, let's dive a little bit deep inside the conjugation in diagrammatic view. Okay. For example, what is sigma bond? This is which type of overlapping? Okay, first of all tell me, this is a sigma bond, this is a pi bond. Okay, this one is the sigma bond, this one is the pi bond. Electrons present in the sigma bond are called sigma electron, and electrons present in the pi bond are called pi electrons. Okay, so in the mesomeric effect or in the conjugation, you will never see the delocalization of that sigma bond or electrons, sigma bond electrons. You will always see the delocalization of that pi electrons only. For example, if I give you an example, take benzene or phenol. In this what will happen? You will see this pi bond, for example, this oxygen will donate electron. Either it can, if it is highly electronegative, it can attract the electron, but since here hydrogen is also attached with the oxygen, so it will donate its lone pair. So what will happen? This lone pair will come here. When this lone pair will come here, what will happen? There will be 5 bond in that carbon. So in that case, what will happen? One bond will be go to that carbon. It will become negatively charged. Okay. In the next step, what will happen? This electron will be this negative charge will be going on that bond, and ultimately what will happen? The structure will be like this. Here you will see double bond. Okay, here you will see double bond, and this double bond, when it will come here, what will happen? This carbon will have now 5 bond. So what will happen? This double bond electrons will be pi bond electron will be going to that carbon. Like this, what will happen? Ultimately shifting of pi electron will take place, but sigma bond electron will be as it is. Okay, so delocalization of pi electron will take place, not the sigma electron. Okay, so this pi electron delocalization ultimately lead to the increase in stability. Why? Because some carbon, if it is having 7 electron on the outermost shell, that means 1 electron is deficient. And if some carbon, now it will become more stable or unstable? It will become unstable. Again, if some carbon has more than 8 electrons, this is one extra electron, again it will become unstable. Why? Because stability is ultimately related to octet. if on the outermost valence shell if 8 electrons are present, that means octet complete. Octet complete means it is highly stable. So this is also unstable, this is also unstable. In that case, what will happen? This single electron, excess electron will be going there in that vacant place. So now it will also have 8 electrons, it will also have 8 electrons. Ultimately what will happen? Octet will complete. And when octet is complete, they will become highly stable. Highly stable, and they will not react further anymore. Why? Because when they are stable, they will not react. And when they are unstable, they will react. And why they will react? To gain the stability. By reacting, they will just increase their stability. Already I have mentioned, in every class I am mentioning that all the organic reactions are taking place. Why? Just to gain the stability. Okay. Now we will see how many different types of conjugations are there. This is very important. Types of conjugation. There are mainly five types of conjugation exist. They are: number 1, pi, sigma, pi. In that case, what will happen? Okay, I'll explain. First, let's see that. Number 2 is pi, sigma, negative charge, or pi, sigma, lone pair. Number 3 is negative charge, sigma, positive charge. And number 4, pi, sigma, positive charge. Number 5, where should I write the number 5? Number 5, pi, sigma, free radical. See, in that case what will happen? These pi bond electrons will be shifted to that place, and that pi bond will be shifting further. If any atom is there, then it will be going on that, and A will be negatively charged. In that case, again what will happen? Pi, sigma, lone pair. No, this is pi, sigma, negative charge. Negative charge means already ultimately it has more electrons, so it will try to donate and it will go on the left side. Already I have given in the example also. For example, in the case of phenol, this oxygen is having lone pair. So this lone pair will be donated here, and what will happen? The double bond will be shifted there. Okay, like this the structure was there, na? So it will shift there. After that, process will continue. In the next step, what will happen? It will come there. This lone pair will be coming there. So the structure will be like this. Next, what will happen? It will go there, and this will go there, and the structure will be like this. So one double bond is there, one double bond is there, another double bond is there, and it will be negatively charged. Okay. Again, in next step, this negative charge will go there. So ultimately, what will happen? The pi bond electron will be shifted from one place to another place. That is delocalization of pi electrons. Okay. In that case, again lone pair is there. So same shifting will be happen. In that case, it is electron deficient. Positively charged means electron deficient. So it needs more electrons. So what will happen? This is negative charge. Negative charge means extra electron is there. So it will donate there, and from there again go there. Same here. Negative double bond sigma, positive charge. Again same thing will happen. So ultimately shifting of pi electron will be taking place. So how many different types of conjugation are there? Number 1 is pi sigma pi. Number 2 is pi sigma negative charge. Number 3 is pi sigma positive charge. Number 4 is pi sigma lone pair. Next, pi sigma positive charge. Next, double bond sigma free radical. That is pi sigma free radical. Okay, am I clear? So these are the conjugations. After that, we will see mesomeric effect. This mesomeric effect is very important, and I will tell you that this mesomeric effect is permanent effect. Inductive effect was permanent effect or temporary effect. Inductive effect was also permanent effect. But what is the difference between inductive effect and mesomeric effect? The difference is that in the inductive effect was taking place mainly due to electronegativity difference. For example, A, B, B. So A has more electronegativity, B and B has same electronegativity. So the electronegativity difference is there in between that A and B. So ultimately this bond will be polar because this A has more electronegativity and this B has less electronegativity. So what will happen? This bond will be polar. But these both the B and B have same electronegativity. So this bond is non-polar. Now, due to the presence of polar adjacent bond, the polarity will also induce on the non-polar adjacent bond. This induction or induce polarity into the non-polar bond due to the presence of adjacent polar bond is called inductive effect. Okay. In inductive effect, what will happen? Electron density will be shifted. Electron density, that is, now what will happen? See, this is more electronegative, so there will be del negative, and it is less electronegative, it will be del positive. Like this it will takes place. Okay. The most important thing is that this is all about electron density, and it is in case of inductive effect. But what about mesomeric effect? In mesomeric effect, direct transfer of electron will takes place. So it is related to electron density, but mesomeric effect is related to electron. It is related to electron. Okay. Due to the presence of lone pair and vacant orbital here, it will donate its electron, and ultimately what will happen? Transfer of electron will take place. Okay. Now, the way inductive effect was permanent effect, mesomeric effect is also permanent effect. Both are permanent. Next thing I want to tell you is that it causes ultimately the increase or decrease in electron density, but it will directly cause the increase in number or decrease in number of electron in the ring. Okay. This will ultimately affect the acid strength or basic strength and stability of carbocation. The most important point about the inductive effect and mesomeric effect is that both will lead to the stability of carbocation. So stability of carbocation is directly proportional to which effect? Carbocation means, see, carbocation means electron deficient. That means it needs more electron or less electron? It needs more electron. Yes or no? Because already it is electron deficient. It is poor, so it needs more money. In the same way, it is electron deficient, so it needs more electron. In that case, which effect should be there? Plus I effect. Which effect should be there? Plus I effect. And if in the case of mesomeric effect, which mesomeric effect should be there? Again, plus M effect. In both cases, stability of carbocation will increase. But if in the case of carb anion, what will happen? It is already rich in electron. So we need to either decrease the electron density or we need to withdraw the electron. So to withdraw the electron, we will use which type of group? The group which will show the minus M effect. Or we will use which type of inductive effect? The group which will show minus I effect. This minus I effect will lead to the decrease in electron density in the central atom and ultimately lead to the stability. And this minus M effect will try to withdraw the electron, and ultimately what will happen? It will also cause the stability of carbon ion. So stability of carbocation is directly proportional to plus I effect and plus M effect, but it is inversely proportional to minus I effect and minus M effect. Okay, so can you please tell me a group which will show plus I effect? Plus I effect will be shown by alkyl group. Alkyl group, that is CH3, CH3, CH2. All these will show plus I effect. CH3, CH3, CH2. It will show plus I effect. Okay, minus I effect will be shown by X. Minus I effect will be shown by X. Okay, in the same way, plus M effect will be shown by which one? The one which is having more electron. Which is having more electron. For example, OH. This OH oxygen is having lone pair. Excess electron is there, yes or no? So it will try to donate that electron. Yes or no? Okay. And plus M effect will be shown by NO2. Like this. Okay? Am I clear? So you can say that which one is more stable? In that case, C positive, that is carbocation, CH3, CH3, CH3. Second one is having carbocation, NH2, CH3, CH3. Can you please tell me which one will be more stable? The one which is having electron deficient in the central atom needs more electron. So this CH3 will show more electron density. This CH3 will also increase more electron density. This CH3 will also increase more electron density on the carbocation. But here you will see two CH3 will show plus I effect, but one NH2 is there. And this NH2 will do, this NH2 will give the directly electron. They will increase the electron density, but this NH2 will donate the electron. So ultimately it will increase the electron. So it will show plus M effect and it will show plus I effect. Here it will show plus I effect. All of three will show plus I effect only. So ultimately plus M effect is more stronger than plus I effect. Okay. So what will be the answer? 2 will be more stable than 1. So this is 2 and this is 1. So what will be the answer? 2 will be more stable than 1. What I mean to say in that question, that plus M or minus M, ultimately M, mesomeric effect is more stronger. Mesomeric effect is more stronger than inductive effect. You have to remember that. Note it down. Mesomeric effect is more stronger than inductive effect. Am I clear? Okay. Next thing I want to tell you is that which one will show more acidity and which one will show less acidity. That is acid strength and basic strength. Before going to acid strength and basic strength, you have to understand what is acid strength. Acid strength is the ability to donate the H+. For example, if you take benzoic acid, okay, this is benzoic acid. In this what will happen? If this benzoic acid will donate that H+, then ultimately what will happen? O- will be there. And this O- will be stabilized by aromaticity. Yes or no? See, this negative charge sigma pi, pi, sigma pi. Like this you have to see. Okay, for example, everything is done or everything is wrong shaped.